Hello friends, today I'm going to solve LeetCode number 1318, minimum flips to make A or B equal to C. Okay, so here we are given three positive numbers A, B and C, and we need to return the minimum number of flips which is required in A or B so that we get A bitwise OR B equals to C. So we are going to take the bitwise OR of A and B, and we need to get the value C. So to get the value C, we might need to change some of the bits of A, some of the bits of B to get this value. So how many number of bits minimum should we need to change to get the value of C? That is what our result will be. So what is a flip? A flip is like changing a single bit of 1 to 0 or changing a bit 0 to 1. So now here we are given an example, so let's look at this example. So before that, let's see how can we get a 1. So if we need a value 1, we know that 1 or 0 gives us 1. So to get the value 1, at least one of the two bits should be equals to 1 to result into a 1 value, right? And to get a value 0, both the bits should be equals to 0, right? To get a value 0. So this is the condition that we are going to use. All right, so now let's check this example and see how we could solve this problem. So 2, what's 2? 2 is 0 1 0, right? What's 6? It's 1 1 0, right? And what's 5? It's 1 0 1. Okay, so we need the value of 5 when we are making bitwise OR of these two values. But are we getting a value 5 when we do bitwise operation of these two values? Let's check. 0 and 0 or 1. So when we do 0 or 1, we are going to get 1, right? At least 1 means it's 1. We have two 1s, that's definitely a 1. We have two zeros, so that's a 0. So here we are getting 1 1 0, which is equals to 6, but we need a value 1 0 1, which is equals to 5. So how do we get this value? We need to make some bitwise changes, some bit flips in either A or B. So let's see how we could do that. So let's start from the very end of the value C, and the last bit of C is equals to 1, which means that we need at least 1, right? To get a bit of 1, we need at least one of them to be equals to 1. So let's check the last bit of A. It is equals to 0. Last bit of B, it is equals to 0, which means that we need to flip either one of these. Okay, so our answer would be equals to 1 plus 1. Okay, because we need to flip either one of these. We could flip any one, so let's just flip A. Now next, that would give us a 1 here. Now let's check the second last bit. Okay, so in this bit we have a value 0. Now for 0, what do we need? Both the values should be equals to 0, right? So what about this? We have 1 and we have 1 here, so both of them are equals to 2, right? So we are going to add a value 2 here, and now we are going to flip both of them. So we flip both of them, and here we get a value 0. Okay, so these two 0 zeros give us 0. Now next we need a 1, right? So the first is 1. Now we have a value 0, we have value 1, so this gives us 1. So well, we did not have to change the first bit. So now we have our answer, which is equals to 5, right? So how many bits did we have to change? We have to change only 3 bits, right? So that is our answer, and that is how we're going to perform the solution. So let me just write down this. So what are we going to do is we are going to check bit by bit. Okay, and while we're checking bit by bit, we start from the last bit until A, B and C is not 0. So either one of them is not 0 until either A, B and C is not 0. We just keep on iterating. So while we are iterating, what do is we check the last bit. Okay, so this will be here, this will go here because we are checking our last bit. And while we are checking our last bit, if C is the last bit of C, okay, of C is equals to 0, equals to 1, let's say equals to 1, which means that at least one of them should be equals to 1, right? So if both of them are 0, we only have to change 1. If one of them are 1, then we don't have to change anything, right? So maximum number of changes that we could make is only flips we would need to make is only 1. So here we will be checking, okay, I'm just going to do like this, and here we will be checking if both last bit of both A and B is equals to 0, then add 1 to answer. Okay, if both of them are 0 only, then we are going to add 1 because only one of them should be equals to 0. Okay, now if last bit of C is equals to 0, okay, if that is the case, then how are we going to do that? So for that case, to be equals to 0, both the bits in A and B should be equals to 0, right? So the maximum number of flip, we might have to change both the bits, right? So there is a chance we could either change 1 or 2. So here, if last bit of A is equals to 0 is not equals to 0, then answer, add 1 to answer, increase order. Okay, I'm just going to add 1 to the answer. Okay, and again, if last bit of B is also not equals to 0, then again add 1 to the answer. All right, so now that we have these values, the algorithm ready, now let's start our code. Okay, so what are we going to do first? So let us first create our answer variable, which will be equals to 0 beginning, and now we are going to loop until and unless A, B and C are not equals to 0. So I'm not doing here like I'm doing a bitwise OR here. So bitwise OR means either one of them is 1, then like we keep on iterating. If one of them is 0, if all of them are 0, then that would be equals to 0 and we will skip out of this OR loop. Instead of doing this, we could also do like we could also check like A is not equals to 0 or B is not equals to 0 or okay, sorry, here C is not equals to 0. We could do this as well, or the short form of this is A is not equal A or B or C, because in JavaScript 1 is treated as true and 0 is treated as false. Okay, so you could just do it this way, and if A is equals to 1, then that would be true, and if any one of them is equals to 0, then that would be treated as false. Okay, so this can be written as this. Okay, and now this can also be written as this, because like here we are checking if they are at least 1, right, if they are not 0, and that is the same thing here we are doing. But here we are using bitwise operator. Here it is logical OR operator. Okay, so that's the only difference. Now while in the while loop, what do? Once we get into the loop, we check the bits, right? So the last bit, we need the last bit of C. So how do we get the last bit of C? We can do the AND operation. Okay, let me give an example. So we have something like this, and if I do an AND of these with 1, what am I gonna get? And with 1 is equals to 0 0 0, and the last bit, whatever the last bit of this is, will be the result here. If this were 0, then I would get a 0 here because I'm doing an AND operation. So that will all depend on this value because this is always 1, and the rest of the values, since I'm not supplying any values here, that always means that it's prepended with zeros. Okay, so zeros and with 0 is always 0, and with 1 is equals to the value of the variable that we are performing AND with. So that is what I'm going to do to get the value of last bit of C. So I'm going to do bitwise with and here, if this is equals to 1, equals to 1 means at least one of them should be equals to 1, right? So if last bit of both A and B is equals to 0, then we add 1 to the answer. So we need to check here if A, last bit of A, we need the last bit of A. So A and 1 equals 0, and B ampersand 1 equals 0. That is when we do answer plus. Okay, so how can we like shorten this? Since we are checking it with 0, so I'm just going to add a not sign here, and that would be the same as like doing A and 1 equals to 0. Okay, so now this is for C equals to 1, else if C is equals to 0, then we have to check for both, right? So that would be answer. I'm just going to answer plus equals to A and 1. So if A ampersand 1 is equals to 0, then we don't have to add anything. Else if it is equals to 1, that this would result in 1, and we add a value 1. And same with B ampersand 1, and we add the value B here. Okay, so this is how we are doing our calculation. Finally, we return our answer. Okay, so now here I can do one more small optimization, that is, instead of doing if, what I can do is I can cut this out, and my answer would be A plus equals this value. So if both of them are equals to 0, then this value will be true, and as I already told, true is corresponding to 1, so that 1 would be added to our answer. So now let's try to run our code and see the result. Okay, I missed very important thing here. So what are we doing here? What we check the last bit, and then we move on to the second last, right? And then the next one before that, and so on, right? But here we are always checking the last bit only. So for that, what I need to do is I need to shift the like values towards the right. So if I'm shifting it towards the right, so what happens is, if I have this and if I shift this towards the right, then this would be equals to 1 0 0, and it will be prepended with a value of 0. So that is how we are actually going to do this. So B shift right shift, and then C right shift by 1. Okay, and now let's try to run it. Awesome, let's submit this. Great. So let's talk about the time complexity. Since we are performing a while operation over a, b, and c, right? The values a, b, and c, and we are given that the length, the value of a could be 10 to the power 9, b could be 10 to the power 9, and c could also be 10 to the power 9. How so um that would the time complexity would be based on the value of this, so that would be a maximum of 10 power 9. Right, yes, because that would depend on the number of bits of each of these values. So if the number of bit of any one of these values is equals to n, which is the highest number of bit, then that will be the time complexity, and the space complexity here is constant. So I hope you liked my solution. Let me know in the comments down below. Thank you.